Mercury is the planet humans noticed before we had the word planet. It's that quick little light that pops up low over the horizon just after sunset or just before sunrise, then vanishes again. For a long time, people thought they were seeing two different objects, one in the morning, one in the evening, until careful watchers realized it was the same world playing both roles. The Romans gave it the name Mercury after their fast-moving messenger god. Fitting. It laps the sun in 88 days and never lingers far from the glare. A big early milestone came in 1631 when Pierre Gassendi watched a tiny black dot slide across the face of the sun, Mercury in transit, exactly when Kepler's table said it would. That was a mic drop moment for we actually understand this clockwork. Jump forward 3 centuries to the 1960s. Radio astronomers pinged Mercury with radar and discovered it doesn't keep one face to the sun like our moon keeps to Earth. Instead, it rotates 3 times for every 2 laps around the sun. That odd rhythm explains one of Mercury's signature party tricks. Its solar day, sunrise to sunrise, lasts about 176 Earth days, which is twice as long as its year. Fast year, slow day. Nature, apparently, enjoys a contradiction. Spacecraft turned the bright dot into a real place. Mariner 10 flew past in the 1970s and mapped roughly half the surface. Then Messenger arrived in 2011, went into orbit, and gave us the works. Global maps, chemistry, gravity, a look at the magnetic field, and a close-up of the super-thin atmosphere, which is barely an atmosphere at all. The next visitor, BepiColombo, is on its way to settle into orbit and keep asking hard questions. Before we dive into the gritty details, here's the clean snapshot, with Earth as the measuring stick. Mercury is small, about 4,880 kilometers across, a little more than a third of Earth's diameter. It's light in size but heavy in nature, very dense for its scale, because it's built around an oversized iron core with a relatively thin rocky shell. Stand on its surface, and you'd weigh about 38% of what you weigh here. A 180-pound person on Earth would be roughly 68 pounds on Mercury. It lives close to the fire at an average of 0.39 astronomical units from the sun. Call it 40% of Earth's distance, and it races around that track in those 88 days. Thanks to that 3-to-2 spin orbit lock, the daylight crawl is brutally long. You could celebrate 2 Mercury New Years during one Mercury day, which is funny until you remember the temperature swing. Let's compare atmospheres, which is a generous term for what Mercury has. On Earth, air is a thick blanket, mostly nitrogen and oxygen, about 1 bar at sea level. It moves heat around, makes winds and clouds, and keeps daytime from cooking and nighttime from freezing. On Mercury, there is no blanket. There's a trace exosphere, a sprinkle of atoms, sodium, potassium, oxygen, calcium, magnesium, kicked off the surface by sunlight and micrometeoroids, then swept away by the solar wind. It's a revolving door, not a sky. That's why Mercury's temperatures are so extreme. In direct sun, rocks can hit roughly 430 degrees Celsius, pizza oven hot. In darkness, they fall to around minus 180 degrees Celsius, deep freeze cold. Same star, same planet, 2 wildly different faces because there's no air to smooth anything out. The lack of air changes everything else too. On Earth, weather and water constantly edit the landscape. Rain carves, wind drifts, plants pry, and even deserts have dust the air can push around. On Mercury, there's none of that. The editors are micrometeoroids, sunlight, and the solar wind. They chip, sputter, and gradually knock atoms loose. It's quiet work, but over billions of years it leaves a fingerprint. That thin exosphere and, surprisingly, a faint sodium tail pushed anti-sunward, like Mercury is wearing a tiny comet costume. Now, the surface. If you glanced at a photo, you'd say, that looks like the moon, and you wouldn't be wrong. Mercury is covered in craters from scaled-up potholes to enormous basins. The celebrity scar is Caloris, more than 1,500 kilometers wide, a crater the size of a country. After big hits like that, lava flooded lowlands and cooled into smooth plains. The big difference from Earth is the why behind the cliffs and ridges. Our mountains are mostly built by plate tectonics, plates sliding, colliding, and crumpling. Mercury has no plates. Its most dramatic landforms are long, high, wrinkle cliffs, created because the planet literally shrank as it cooled. The iron core lost heat and solidified inward over time. The whole interior contracted by a few kilometers in radius, and the brittle crust had no choice but to buckle. The result is lobate scarps, cliffs hundreds of kilometers long and up to a couple of kilometers high, slicing across craters and lava plains like someone pinched the planet and left fold marks. There's another Mercury-only feature you don't see on Earth, bright, fresh-looking pits called hollows. Think of them as little bite marks where volatile, barren minerals at the surface got zapped by sunlight and space particles and simply disappeared into space, leaving shallow depressions with crisp, bright halos. They look young because, on an airless world, nothing smears them out. No rain, no frost heave, no moss. Just pits, clean and blunt. One more surprise, and it's a good one. Ice. How do you get water ice on the closest planet to the sun? Geometry. Mercury's axis tilt is basically zero. So at the poles, the sun never climbs high in the sky. Some deep polar craters have floors that sunlight never reaches. Those permanent shadows are cold traps, colder than liquid nitrogen, and they can store water ice for millions of years. Delivery service is provided by comets and water-bearing asteroids. A little water migrates, hits the deep freeze, and stays. Earth has polar cold too, but our weather is always stirring the pot. Mercury's stillness lets the ice sit in the dark and wait. Mercury's magnetic field is small but real, about 1% of Earth's field at the surface, and it's oddly shifted toward the north. To have a field at all, you need a moving, conducting fluid inside. In Earth's case, that's the liquid outer core. In Mercury's case, it's a thinner, partly molten metallic shell still convecting enough to run a weak dynamo. If you're wondering why a small, old planet hasn't cooled to the point of total freeze-up, welcome to the club. That's one of the puzzles Messenger and BepiColombo were built to poke. What composition, heat sources, and layering keep that core mobile? And no, Mercury has no moons. 2 reasons. It's small, so its gravitational grip is modest, and it orbits deep in the sun's gravity well, which tugs hard on anything trying to stick around. If a rock ever did settle into orbit, the sun would eventually nudge it out or in. Earth got lucky with a giant impact that made a disk of debris far from the sun's direct sabotage, and we're big enough to hold on to the result. Mercury is more like a studio apartment. Just the planet and the star out the window. Even Mercury's orbit carries a bit of fame. It's noticeably elliptical, closer to the sun at one end than the other, and the ellipse itself slowly rotates over time, a precession. Most of that is explained by tugs from other planets. The leftover inch of precession, the annoying 43 arcseconds per century, didn't fit Newton's math. General relativity cleaned it up perfectly. The smallest planet helped nail down the biggest idea in gravity. So if you collect the basics into one image you can hold in your head, it goes like this. A small, dense world with a huge metal core, no protective air, brutal day-night temperature swings, a surface punched by ancient impacts and later ironed by lava, long cliffs from a planet that shrank, bright pits where sunlight literally took bites out of the rock, real ice hiding forever in the dark, a weak, lopsided magnetic field buzzing over it all, and an orbit that once told Einstein, yep, your equations work. Compared to Earth, Mercury is simpler in parts and harsher in others. We've got oceans, air, weather, and moving plates. Mercury has rock, metal, sunlight, shadow, and time. If Earth is a living room with a climate system, Mercury is the engine block left running near a furnace. That's the groundwork, what it is, how we found out, and how it compares to home. Next, we can zoom in and live on the surface for a while. What you'd see underfoot, how the cliffs line up, and how a world without air still manages to change. Let's step onto the surface and keep it simple. Mercury looks like someone took the moon, turned the contrast up, and added a few weird twists. The ground is a dry, powdery blanket of crushed rock, regolith from countless micrometeoroid hits. The horizon feels close because the planet is small and the shadows are razor sharp. With no air, sunlight doesn't scatter. If you stood near the equator at noon, the sky would be black, the sun painfully bright, and the ground in front of you baked. Walk into shade and the temperature would drop like a rock. There's no breeze, no clouds, no sound, but your own equipment clicking. Mercury does quiet very well. The most famous scar on the planet is Caloris Basin, an impact feature more than 1,000 miles wide. Picture a country-sized bowl punched into the crust, surrounded by rings of uplifted mountains. Later, lava flowed in and smoothed large patches of the floor, so parts of Caloris look oddly level compared to the battered terrain around it. On Earth, big impacts are quickly erased by weather and plate tectonics. Here, nothing erases anything quickly. Craters overlap craters like coffee stains on a workshop floor. You can read the history because nobody bothered to clean it up. Then there are the wrinkle cliffs, properly called scarps, long curved cliffs that cut across plains and even across crater rims like fold marks on a crumpled map. They exist because Mercury literally shrank as it cooled. The big iron core lost heat. The whole interior contracted by a few kilometers in radius, and the brittle crust had to buckle to fit. On Earth, mountains mostly come from plates colliding. On Mercury, mountains are the planet pinching itself. Some scarps are hundreds of kilometers long and a couple of kilometers high. They are not subtle. Volcanism did its share of work here too. After the worst of the bombardment, magma found paths to the surface and flooded low areas, making the smooth plains that cover huge regions. In places, we also see evidence for explosive eruptions. Think gas-charged bursts that scatter glassy debris. That's surprising for a world this close to the sun, but the chemistry checks out. Mercury's surface rocks are unusually rich in sulfur and poor in oxygen compared to Earth's, which helps certain gases build up and blow. If the moon is mostly a story of quiet lava seas, Mercury's story includes some fireworks. One of Mercury's quirks is the hollow. These are bright, shallow pits with crisp edges often clustered on or near certain rock types. The simple version: some minerals near the surface contain volatile elements, stuff that doesn't like heat and radiation. On airless Mercury, harsh sunlight and particle hits can kick those atoms out of the crystal structure. The material just goes. The surface collapses a little where it's been emptied out, leaving a clean-edged pit with fresh-looking bright halos. On Earth, rain, wind, and life would smear and stain that kind of feature quickly. On Mercury, it stays tidy. Now, about the air, which isn't air. Mercury has an exosphere, not an atmosphere. Imagine a few atoms here and there: sodium, potassium, oxygen, calcium, magnesium, knocked loose from the surface by sunlight and micrometeoroids. Those atoms hop in ballistic arcs and often escape entirely. The solar wind shoves them away, building a faint sodium tail that streams off anti-sunward like a tiny comet. Compare that to Earth's atmosphere: thick, mostly nitrogen and oxygen, about 1 bar at sea level, full of moving air masses that make weather and smooth out temperature swings. Earth's air is a blanket. Mercury's air is a sprinkle. The difference shows up everywhere. On Earth, daytime might be warm and nighttime cool, but the air keeps the range human-sized most of the time. On Mercury, there's no insulation. Sunlit ground can hit around 430 degrees Celsius, hot enough to ruin cookware, while the night plunges to around minus 180 degrees Celsius. The result is brutal thermal stress. Rocks expand, contract, and crack just from the daily cycle. Over billions of years, that helps grind the surface into regolith, even without wind or rain. Space weather does the rest. Solar wind particles sputter atoms out of minerals, and micrometeoroids sandblast everything at a slow, merciless pace. Move to the poles and the script flips. Mercury's axis is almost perfectly upright, so in some deep polar craters, the sun never rises high enough to touch the floor. Those pockets sit in permanent shadow and reach temperatures cold enough to preserve water ice for millions of years. How does water get there on a planet with no air and wild heat? Delivery plus geometry. Comets and water-bearing asteroids hit. Some water migrates as vapor, and whatever drifts into those deep freeze shadows stays. Earth has polar cold and even some places that keep ice year-round, but our thick air moves heat around, and our tilt gives us seasons. Mercury's stillness and tiny tilt let the ice hide in the dark and ignore the oven next door. What's under your boots? A thin rocky shell over a very large metal heart. Mercury's density gives it away. For such a small planet, it's heavy. The best models say there's a solid inner core and a liquid outer core made mostly of iron, with some other elements mixed in. Then a relatively thin mantle and crust above that. The core is proportionally huge. By volume, it dominates the planet. On Earth, the iron core is big, but the rocky mantle is bigger. On Mercury, the core steals the show. That oversized core is also why Mercury has a magnetic field at all. To run a dynamo, you need a moving, electrically conducting fluid. Earth does it with a thick liquid outer core that convects. Hot material rises, cool material sinks, the planet rotates, and the motion organizes into a global field. Mercury manages a smaller, weaker version of the same thing. Its field is only about 1% as strong at the surface as Earth's, and it's oddly shifted toward the north, which hints that the liquid part of the core may be layered or uneven. But the headline is simple. For a small old planet, the inside is not totally frozen. Something is still moving down there. What does a magnetic field buy you this close to the sun? A little protection and a lot of drama. Mercury's magnetosphere, the bubble carved out of the solar wind, is small and ragged. Solar storms can connect directly to the field and funnel charged particles right down onto the surface. On Earth, most of that energy gets spread out in our upper atmosphere and shows up as auroras near the poles. On Mercury, there's no air to glow, so the aurora is more like invisible space lightning striking bare ground. If you're a spacecraft, you feel it in your instruments. Time behaves weirdly here, and not just because a Mercury day outlasts a Mercury year. The sun changes apparent size over that long day because the planet's orbit is noticeably lopsided, closer to the sun at one end than the other. Near closest approach, the planet's orbital speed briefly wins the tug-of-war with rotation, and the sun can appear to slow, pause, or inch backward near local noon before continuing its crawl across the sky. It's not an illusion. It's orbital mechanics showing off. Earth doesn't do this because our orbit is nearly circular and our day is short compared to our year. Mercury also wins a trivia night with a physics fact. The way its closest approach point drifts over time, the precession of its perihelion, didn't match Newton's equations by a small but stubborn amount. General relativity fixed it perfectly. You don't feel that living on the surface, but it's a nice reminder that this small world helped confirm a big idea. Does Mercury have moons or rings? No and no. Two strikes. First, it's small, so its gravity well isn't deep. Second, it's orbiting very close to the sun, which constantly tugs on anything trying to orbit Mercury. If a small moon ever formed or was captured, the sun would likely destabilize it over time. Earth got a massive lucky break with a giant impact early on that made a disk of debris. We're big enough and far enough from the sun to keep the moon. Mercury is more like a lone tenant in a tiny orbit. No roommates allowed. How did we learn all of this from more than 90 million miles away? A short highlight reel. Mariner 10 flew by 3 times in the 1970s and gave us our first close-ups. Half a world mapped, a magnetic field confirmed, and a vibe that said, this is not just the moon. Decades later, Messenger braked into orbit, mapped the rest, measured gravity and chemistry, sniffed the exosphere, and found ice in the dark. It also spotted those bright hollows and gave us a better view of the wrinkle cliffs. When it ran out of fuel, the team sent it down in a planned impact, a proper finish, after a phenomenal run. The joint European-Japanese mission, BepiColombo, has been doing a series of gravity assist flybys and will settle into orbit to keep pushing on the remaining questions. How the core is structured, how the magnetic field works, how the exosphere breathes, and how those polar deposits are arranged. If you want a practical takeaway for your own sky, Mercury can be seen with the naked eye, but only if you chase it at the right times. low in the west after sunset, or low in the east before sunrise during its greatest elongations. It never strays far from the sun, so you need a clean horizon and some patience. Binoculars help. A small telescope shows phases like a tiny Venus. During a transit, rare but spectacular with proper solar filters, you can watch it crawl across the sun as a perfect pinhole of black. It's a reminder that even the smallest planet leaves a clean, measurable mark. So that's Mercury from the ground up. A small metal-heavy world with a black sky, hard light, and geology that makes sense once you accept the rules. No air, big core, slow cooling, and the sun as a noisy neighbor. Compared to Earth, it's simpler in tools and harsher in edges. But the simplicity is honest. If Earth is a complicated house with many rooms, Mercury is the engine block in the garage. Hot here, cold there, iron at the center, and everything else arranged by heat, gravity, and time. Next, we can zoom further into the interior and the magnetic puzzle, and then take a closer look at the polar ice and what it tells us about how even an airless world can hold on to something as delicate as water. Let's go inside the planet for a minute, because the outside only makes full sense once you know what's under it. Mercury is basically a metal heart wearing a thin stone coat. The core takes up most of the planet's volume and a big share of its mass. Think of Earth. We have a metal core too, but our rocky mantle is the main bulk. On Mercury, the core hogs the space. The best evidence says there's a solid inner core surrounded by a liquid outer core made mostly of iron, with some other elements mixed in. That liquid layer is crucial. Moving, electrically conducting metal is how you run a planetary dynamo. No motion, no field. Mercury still has motion, less than Earth, but enough, which is why a small old planet can carry a global magnetic field at all. That field is weak compared to ours, about 1% at the surface, and it's not centered. It's shifted toward the north. That asymmetry hints that the core isn't a simple, uniform ball of metal. Layers with slightly different compositions or temperatures can change how the liquid circulates. On Earth, we talk about convection like a boiling pot. On Mercury, it's more like a slow rolling stir. Still circulation, just thinner and more fragile. The result in space is a small magnetosphere that gets slapped around by the solar wind. Where Earth has a big, sturdy magnetic bubble, Mercury's bubble is tight and drafty. Sometimes the sun's charged particles connect right onto Mercury's field lines and run down to the surface. There's no air to catch that energy and glow, so you don't get a light show. You get chemistry. Atoms knocked loose, minerals altered, a little more sprinkled into that exosphere. Now the rhythm that sets Mercury's sense of time. The 3-to-2 spin-orbit resonance sounds like jargon, but the idea is clean. Picture two gears meshing. For every 2 laps around the sun, Mercury spins 3 times. It didn't start that way. It got captured as its rotation slowed over time. The orbit is stretched, more oval than Earth's, so the tides from the sun aren't steady. They tug harder near closest approach, softer farther out. And that on-off pattern makes the 3-to-2 slot the stable resting place. The side effect is a very long solar day. If you were standing on the surface, the sun would crawl. Near perihelion, it would even appear to slow down, stop, and shuffle backward for a bit before resuming its path. Earth never does this. because our orbit is close to circular and our day is quick compared to our year. Mercury makes you feel the math. All of this, thin or absent air, the long day, the tight magnetosphere, feeds back into the surface you'd actually see. The top layer is regolith, crushed rock from billions of tiny hits and thermal fatigue. With no wind or water to move grains around, the texture is set by impacts and temperature alone. At noon, the ground expands. At night, it contracts. Rocks crack. The surface gets crumbly. If you've handled a dry clay pot that's been through too many heating cycles, you've felt the same kind of stress, just at kitchen scale. Mercury does it at planet scale. Let's take a walking tour. Start near the equator on a smooth plain. These are wide sheets of frozen lava that filled low areas after the worst of the impacts. The ground under your boots would be dark, fine, and gently rolling, broken by craters of all sizes. Ahead, a scarp lifts out of the plain, one of those wrinkle cliffs. It's long, curved, and abrupt, like a massive stack of rock slabs tipped upward. On Earth, a cliff like that usually marks a place where plates met or a fault accommodated sideways motion. Here, it marks global shrinkage. The planet got smaller by a few kilometers in radius as the interior cooled, and the crust had to wrinkle to fit. That's the difference in one sentence. On Earth, mountains grow from moving plates. On Mercury, cliffs grow because the whole planet tightened its belt. Now hop to the poles. The light is weird. The sun skims the horizon. The crater rims glow. The floors are black pits. In some of those pits, the temperature is so low that water ice can sit for millions of years without going anywhere. It's not that Mercury has water in the Earth sense. There are no lakes. Instead, the system acts like a cold trap. Impacts deliver water. Some of it migrates as vapor. Anything that drifts into those permanent shadows freezes and stays. Earth has cold and shadow too, but our atmosphere moves heat around, and our seasons tilt the light higher or lower over the year. Mercury's near-zero tilt keeps those shadows locked. Geometry beats proximity. Back at mid-latitudes, look for something you won't see here at home: the hollows. They're not impact craters. They're shallow pits with bright halos, often clustered on certain types of rock. The best explanation is that some minerals hold onto elements that don't like Mercury's surface environment. Harsh sunlight and particle hits drive those elements off. The supporting structure fails, and the surface collapses a little, leaving a pit. On Earth, weather would smear and stain that feature in short order. On Mercury, it stays fresh-looking because nothing bulldozes it. You might wonder where the volcanoes are. The short answer is old. The big eruptions that made the plains happened a long time ago. We see their results, but we don't see active vents. Earth stays geologically busy because heat is trapped under a thick blanket of air and water, and because plate tectonics recycles the crust and pumps material around. Mercury is smaller, drier, and exposed. It lost heat faster and quieted down. The planet still changes, just in slow motion. New small craters appear. The exosphere breathes a bit as meteor streams come and go. The core continues to crystallize. The magnetic field drifts. If you're the sort who likes a clean comparison chart, here's the short version without the chart. Atmosphere. Earth has one. Mercury basically doesn't. Temperature. Earth's is moderated by air and oceans. Mercury's flips from oven to freezer because there's no insulation. tectonics. Earth has moving plates. Mercury has global contraction scars. Water. Earth's is everywhere at the surface. Mercury's hides as ice in dark craters near the poles. Magnetism. Earth's is strong and centered. Mercury's is weak and weirdly offset, but proves the core isn't dead. Moons. Earth has one big one. Mercury has none. Day and year. Earth's day is 24 hours, and its year 365 days. Mercury's day is about 176 Earth days, and its year 88. If Earth is a climate machine, Mercury is a thermal experiment. And because every good story gets better with a few proper nouns, let's revisit the human visits. Mariner 10 gave us the first close-ups. Half a planet, a confirmed magnetic field, a hint that Mercury wasn't just the moon, but closer. Then Messenger did the heavy lifting, full global mapping, gravity and chemistry, the discovery of polar ice signatures, those bright hollows, the offset magnetic field, and the fine print of the wrinkle cliffs. When fuel was gone, the team drove the spacecraft into the surface. No drama, just a neat final dot on the map. The next chapter is BepiColombo, a pair of orbiters flying together designed to split the job. One focused on the surface and interior, the other on the magnetosphere and exosphere. It's the kind of mission you launch when you're done asking, what is it? And you're ready to ask, how exactly does it work? Why should anyone care beyond trivia? Because Mercury strips a rocky planet down to its fundamentals. Without air and oceans, you see what heat, gravity, and time do by themselves. Its oversized core tells you something about building worlds near a hot star. Its shrinking crust tells you about cooling. Its odd spin-orbit lock tells you how tides and eccentric orbits settle. Its polar ice proves that tilt and topography can beat average temperature. And its little mismatch with Newton's predictions helped confirm a new theory of gravity. That's a lot of lessons from a world you can cover with a single finger on a classroom poster. If you go outside on the right evening, you can still catch it the way ancient observers did. A bright point hugging the glow there for half an hour and gone. Through binoculars, it's cleaner. Through a small telescope, you'll see it as a tiny crescent or a small gibbous disk. During a transit, rare but worth planning for with safe solar gear, it's a perfect black pinhole sliding across the sun. No frills, no clouds, just a stubborn, dense planet doing exactly what the math says it will do. And that's the appeal here. Mercury is simple enough to explain without hand-waving, but strange enough to keep surprising you once you look closely. We learned Mercury the slow, honest way. First came the naked eye, then small telescopes that showed it changing size and showing phases like a tiny Venus, always glued to the twilight. In the 1960s, we bounced radar off it and heard the echo tell us the planet's spin. 3 turns for every 2 trips around the sun. After that, we stopped guessing and started visiting. Mariner 10 zipped past 3 times in the 70s and gave us our first close portraits. A magnetic field we didn't expect, a giant impact basin called Caloris, and a face that looked moon-like, but not quite. Then there was a long quiet. Decades later, Messenger dropped into orbit and turned that bright point into a mapped world. It measured the chemistry of the crust, the bumps and slopes of the ground, the gravity tug of the core, and the shape and offset of the magnetic field. It caught the telltale signs of water ice hiding in permanent shadow at the poles and found those strange bright pits called hollows. When its fuel ran out, the team let it dive to the surface, a tidy full stop at the end of a very good sentence. The next chapter is BepiColombo, a European-Japanese pair of orbiters that will settle in and keep asking the fussy questions. Exactly how the core is layered, why the magnetic field is lopsided, and how that whisper-thin exosphere breathes through a long, slow day. If you could stand on Mercury, you'd notice how sharp everything looks. With no air to scatter light, shadows have crisp, razor edges. The ground is a blanket of crushed rock made by billions of tiny impacts and the simple violence of heating and cooling. The big landmarks are easy to spot. Caloris Basin is a country-sized bowl punched into the crust. Later, lava rose and leveled parts of its floor, so some of it looks flatter than it has any right to be. Walk away from Caloris, and you'll find the planet's signature wrinkles, long curved cliffs where the crust buckled as the inside of Mercury shrank. Earth builds mountain ranges by shoving plates together. Mercury built cliffs by tightening its belt. Some of those scarps run for hundreds of kilometers and rise a couple of kilometers high. They cut straight across older craters and lava plains like fold marks pressed into a map. Every so often, you'd come across something Earth simply doesn't do, a field of hollows. They're shallow, bright-edged pits, not made by impacts, but by minerals losing the ingredients that keep them stable. Harsh sunlight and particle hits knock volatile atoms out of the lattice. The surface collapses a little and leaves a crisp-edged bite mark. On our planet, weather would smear that kind of feature in a season or two. On Mercury, with no wind or rain to rearrange the scene, the pits sit there looking brand new for a very long time. The air, such as it is, wouldn't help you. Mercury doesn't wear a blanket of gas the way Earth does. It has an exosphere, more a sprinkle than a sky, made of atoms like sodium, potassium, oxygen, and calcium that are knocked off the surface by sunlight and micrometeoroids. Those atoms fly in simple arcs and often escape. The solar wind pushes some into a faint sodium tail that streams away from the sun like a ghost of a comet. On Earth, the atmosphere moves heat around, softens the highs and lows, and creates weather. On Mercury, there's no cushion. Noon can bake the rocks to around 430 degrees Celsius. Night can drop them to roughly minus 180 degrees Celsius. The planet is an oven and a freezer sharing the same address, and which one you get depends entirely on whether you're in the light. Move to the poles, and the rules flip. Mercury's axis tilt is so small that in some deep craters near the poles, the sun never climbs high enough to touch the floor. Those pockets stay in permanent shadow and reach temperatures cold enough to keep water ice stable for millions of years. The supply likely comes from comets and water-bearing asteroids. Some water migrates across the surface as vapor, and anything that wanders into those deep freezes stays. Earth has polar cold too, but our air and seasons are always stirring the pot. On Mercury, geometry beats proximity. If the sun can't see it, it stays frozen. Under your boots, the structure is simple to describe and tricky to make. A very large metal heart with a thin stone shell. Mercury's density gives it away. For a planet this small to be that heavy, the core has to take up most of the volume. The best models put a solid inner core inside a liquid outer core of iron alloy, then a thinner mantle and crust on top. that liquid layer matters. Moving, conducting metal acts like a generator, and that's how you run a magnetic field. Mercury's field is weak, about 1% of Earth's strength at the surface, and it's oddly shifted toward the north, which hints that the core is layered or asymmetric in a way that guides the flow. The magnetosphere it makes is small and ragged. Solar storms can grab hold of the field lines and pour charged particles right down to the surface. On Earth, that energy lights the sky as auroras. On Mercury, with no air to glow, it mostly knocks more atoms loose and feeds the exosphere. Time has its own flavor here. Because of that 3-to-2 spin-orbit resonance, the sun crawls slowly across the sky. Near closest approach to the sun, the planet moves so fast along its stretched-out orbit that the sun can appear to pause, even drift backward for a short while before continuing its lazy loop toward the horizon. Earth doesn't do this. Our day is quick, our orbit nearly round, and our atmosphere hides a lot of the drama. On Mercury, the math is on full display, and no, there are no moons. Mercury is small, and it lives deep in the sun's gravity well. That combination makes it very hard to keep a satellite. Anything that tried to settle into orbit would eventually be tugged off course and either spiral in or drift away. Earth got lucky with a giant impact at the right distance from the sun and a gravity well deep enough to hold on to the debris. Mercury is a solo act. If you're wondering why any of this matters beyond a good set of photos, the payoff is bigger than trivia. Mercury shows what a rocky planet looks like when you strip away the extras. No thick air, no oceans, no moving plates, just heat, gravity, sunlight, and time doing the job. Its oversized core tells us something about building worlds close to a young star, about metal-rich starting material, violent impacts, and early solar winds that can strip and sort. Its global wrinkles show us how small planets cool. Its odd day-year rhythm shows how tides and eccentric orbits settle into stable patterns. Its polar ice proves that tilt and topography can beat average temperature, which matters when we think about resources on the moon and on small bodies. And its tiny mismatch with Newton's predictions a century ago helped confirm general relativity. The smallest planet still managed to check the biggest box in gravity. If you want to see it the old-fashioned way, you still can. Catch it low in the west after sunset, or low in the east before sunrise when it's at its widest angle from the sun. You don't need fancy gear, just a clean horizon and a little patience. Through binoculars, it becomes obvious. Through a small telescope, it shows phases. During a transit with proper solar filters, it's a perfect pinhole crossing the face of the sun. For a world with no air, no moons, and no mercy from the star next door, Mercury makes a surprisingly clear case for why simple physics is compelling. It doesn't need a lot of decoration. It just needs a good look. Here's the thing about Mercury. It looks simple until you try to explain it to a friend, and then you realize it keeps breaking your neat rules. Closest to the sun should mean hottest, right? Except Venus wins hottest because it wears a thick CO2 blanket. Mercury is like standing next to a campfire with no jacket, blazing on the front, freezing on the back, same star, different physics. Mercury also plays tricks with time. It sprints around the sun in 88 days, then drags its feet through a 176-day sunrise to sunrise day. If you lived there, don't You could celebrate 2 New Years during one noon-to-noon day. Around closest approach to the sun, the star can even seem to pause and shuffle backward near local noon before continuing. That isn't Mercury being dramatic. It's what happens when a slow spin meets a lopsided orbit. People still repeat the old myth that Mercury keeps one face to the sun, the way our moon faces Earth. That used to be in textbooks. Radar smacked that story in the 60s. It's 3 spins for every 2 orbits, locked into that rhythm by tides and time. Another outdated idea is that no atmosphere means nothing happens. Tell that to Mercury's exosphere, a whisper of atoms constantly knocked off the surface by sunlight and dust, and to its faint sodium tail being pushed anti-sunward like a ghost of a comet. No weather doesn't mean no action. It just means the action is quiet and relentless. Here's a favorite: ice on the closest planet to the sun. It feels like a prank until you see the geometry. Mercury's tilt is basically 0. In some deep polar craters, sunlight never lands on the floor. Those pockets sit at liquid nitrogen cold, and water ice delivered by comets or water-bearing asteroids can just stay. Earth has cold traps too, but our air and seasons keep stirring the pot. Mercury's stillness lets the ice keep its seat. Mercury also helps settle an argument bigger than itself. Einstein versus maybe there's a hidden planet. For years, the way Mercury's closest approach point drifted didn't match Newton's math. People invented a phantom planet, Vulcan, to explain it. General relativity showed up, did the numbers, and the mismatch vanished. The smallest planet ended up co-signing the biggest gravity theory. One more bit that sounds small, but matters. Mercury has a real magnetic field. It's weak, about 1% of Earth's strength at the surface, and weirdly offset toward the north. But it exists. That means part of the core is still liquid metal and moving. If you want a single sentence that sums up the planet's personality, it's this: too small to be this complicated, and yet here we are. And yes, no moons. Between Mercury's modest gravity and the sun yanking on anything nearby, satellites don't last. If Earth is a house with a big backyard and a moon for a roommate, Mercury is a studio apartment with the star right outside the window. Cozy, bright, and absolutely unforgiving. If you want to see Mercury for yourself, chase it low in twilight at its greatest elongations, west after sunset, east before sunrise, with a clean horizon. Through a small telescope, it shows phases like a tiny Venus. During a transit, rare but worth planning for with solar safe gear, it becomes a perfect ink dot strolling across the sun. A lot of worlds are hard to show people. Mercury gives you a crisp, there it is moment. And sometimes that's all you need to hook someone on the sky.